Hey guys, today we're going to be cutting Daimochi Tsugi. It's a Japanese scarf joint meant to lengthen a piece of wood. In this case, we're going to be cutting it out for the Joinery beam. So if you're kind of wondering where I learned all these Japanese words from, there's Japanese books that explain Japanese joinery, or you could just go to Mr. Chickadee's class, who also talks about each of these joints. So the Joinery beam is essentially the spinal cord of the structure, as opposed to a Western structure where all the bents are connected via the top plates, and the top plates are the biggest one. The Joinery beam is usually one of the largest pieces for the structure. So the Joinery beam is going to connect all the bents via watariago joints. So essentially it's a half lap connected like this. It's a little bit modified. So this is what the joint looks like. So you can see right there. Yep. And so it's called Daimochi Tsugi. It's very good at preventing kind of outward thrust and inward thrust, but not so much at preventing up and down shearing. Usually this joint has some sort of pegging or some sort of bolting or screwing in of the two pieces together. In this case, I modified the design a little bit so that we can have that compressive action without any metal fasteners. Who knows, I may still end up putting some metal in there, but as of right now, I'm not really inclined to do so. We'll see how it goes. I'm going to show you what I have laid out over here, and then we're going to start cutting. Of course, I'm going to be using hand tools, but also some power tools to be able to get the majority of the material off. As you may have come to expect on this channel, we're going to be using centerline layout. So if you're kind of confused as to why I have all these lines kind of drawn on there, or why this big black ink line is on here, that's kind of the hallmark of centerline layout. So this line and the line on the opposite side create a perfectly flat plane, and then there's also a line on this side and this side that also create a plane, and those two planes, their intersection is perfectly perpendicular because I did plumb and level lines on the faces, and the end grain faces, and then snap lines between those pieces. That helps us to lay out all of our joinery on these faces with a fairly good degree of accuracy. First, we're going to talk about the length of this layout. So the length of this joint is 20 inches. So this beam is 8 inches deep. Right, and so the convention for this scarf joint is going to be 2.5 times that depth. So 8 times 2.5 is 20. So it's 10 inches in this direction and 10 inches in that direction. There's my line right there for 10, and there it is for 20. So that's excluding these extra cogs over here at the very end. Those are measured in millimeters. Next thing you can see here is that it looks kind of like a lightning bolt. It comes down, up, and then back down. This centerpiece right here, all it is a 1-inch square. So essentially half an inch out from the line and half an inch up. Half an inch out and half an inch down. So you can see half an inch there, half an inch there. So that's where it is. And this line that wraps around the entire joint is essentially the center of this joint, which is going to help us because now I can line up this center line with the center line of any other joint and be pretty confident that whenever I put this joint together with its opposite, it's going to be exactly where it needs to be, as opposed to relying on a measurement from the edge. I could tell you that on centerline layout, it becomes very evident when a timber is out of square. And that's why I use it, because it allows me a greater degree of accuracy. There's our 1-inch square, and now for these sections right here. These sections are just 30 millimeters. In one, it's going to be a mortise. So I have 30 millimeters right here. And then on this side down here at the very bottom, it's going to be a little cog, essentially a small tenon, but it's also 30 millimeters. And then all I have to do is then connect from this line to that point, which is, if I measure down to get this point right here, it's 2¼ inches. Let me double check that for you. Sorry, 2.5 inches. So 2.5 inches down. So if you follow, we're doing 10 inches from the center to here, and then 2.5 inches down. And then we did our 1-inch square, and so we want the joint to kind of go like this, lightning bolt, back up. And if you follow that general shape, now I have my 45-degree piece right here that's going to prevent this joint from coming apart this way. So I draw my lines and I draw these sections. So this piece right here has no actual measurement, neither does this. The only measurement that I really care about is from the center line to that point. Then I have my 30 millimeters out and I extend that line continuously. So I can use straight edges and line everything up. So you can see I lined up that point, this point, which is the exact same thing as lining up this point and this point. So I move it right here, and you can see those two lines are parallel, and that's perfect. So that is this face. On the top of the face, there's really not much going on. All I have is I've taken that 10-inch line and I've taken it across, which is going to be my stop cut, and now I have this little section right here that's 30 millimeters long, and I've taken that other line and I've drawn it on there, and that's going to be the end of my mortise. So it's going to be essentially 30 millimeters this way 30 millimeters this way, and who knows how deep, right? But it's going to be at an angle following the angle of that slope over here. So that's pretty easy to cut out. To cut this joint out, what I'm going to do is I'm going to take my circular saw, I'm going to rip it right down this line, pretty much getting as close as possible. Then I'm going to do a stop cut over here with my handsaw. I might do that first with a handsaw so I can run right up to it with the circular saw. In fact, I might run all the way out with the circular saw, who knows. Then I'll flip it around and get all this meat off. And then now I can work down to this line and work down to this line with chisels and a plane. So let's get to work. So here's that shoulder cut I was talking about. So we're gonna go ahead and just cut that with a handsaw. Alright, so this part is going to be a little loud. And all I'm going to do is I'm going to cut pretty close to this line. So the thing about this is that this circular saw may cut straight according to that bed, but this surface may not be perfectly flat for the lines that I laid out. So I have to stay off the line. I can't cut on the line like I would want to, because then I got to flip this timber over and do the exact same thing on the opposite side. And so the reason I stopped is I'm checking to see where the blade is going down here. So the blade, sure enough, is kicking toward the line. So I'm staying off the line about a good 1/8 of an inch. That seems like a lot of material, but frankly, with a chisel, it's not going to be that much to take off. Okay, so now I get to do the same thing, and I have to make sure that I'm going to stay on the correct side, the waist side. And you'll notice that I lift the guard. One of the biggest mistakes that I see new people, or people that come to our class, do is that they leave the guard on, and sure enough, when you're cutting at an angle, that guard is going to draw the blade towards it, and so you're not going to cut a straight line, you're going to end up cutting a curve. So, which wouldn't be such a bad thing in this scenario, but normally you don't want to cut a curve, you want to cut a straight line. enough, there it is. Nice, so that's pretty gratifying that we got that big section cut off. So now we can just remove this rest of the piece. Now we can just remove the rest of this lower section with hand tools, a hand plane, and maybe a saw and some chisels. Alright, let's get to it. Alright, so this next step that I'm going to do is I'm going to actually get this section up here perfect before I work on this section, because this part right here only requires some planing. This one requires more work. This is going to be chiseling, sawing, chiseling, planing. So, and also if I went straight to this, then I would run into some issues because this plane is, then I would have to get this surface perfectly flat in comparison to that one. So there's more work essentially for myself. So I'm just going to cut out this whole section and then work on that section afterward. So what I'm going to do is I'm just going to cut it up into small chunks so I can chisel it away from this section. Alright, so this last section, that 45, I'm going to try to do with handsaw. Well, yeah. I'm going to extend this line to that top surface. And we're going to see if we can cut it at an angle like that. I don't think this is going to work out. See if a rip saw works better. Okay, so the rip saw worked better because we were no longer cutting perpendicular to the grain, we were cutting at an angle. So there's a good question, is at what angle do you switch to a rip saw? 45? I would say so. I don't know exactly at what angle you need to change, but anyway, let's remove all this material now. Okay, so that's the section we're going to keep. We're going to start with this guy, so about halfway down. Let's not do that. Okay, so now I'm just going to score it along that line, maybe just staying off about 1 millimeter. So then I can come back and have a pretty good point to start off from. Excellent. Now I'm going to flip it around and do the same exact thing from the opposite side. So now once again we're going to start from back here. So the reason we start from back here is if we do start down here, because the grain is going in this direction, if I were to split it right here, or rather right here, the grain above it would also split, meaning that the reference line that I have would be no good. So I start at the top of the hill and work my way down. So now that we got most of that material removed, now we can turn this back up and work on this surface. So now I'm going to be getting even closer to the line, so now it's important to kind of squat down and see where those lines are. So I'm going to come down over here, and I don't want to go over the line, but the first entry right here, this has got to be the most precise, because that's where I'm going to reference my next cut from. So there it is. As you can see, I'm taking very little this tip over here, making sure I don't cross the line. And if I do, that's perfectly fine. Just need to be prepared to not do it again subsequently, you know, and kind of make sure that it doesn't be a perpetual thing. This is not the nicest grain to work with. As you can see, it's really tearing out on this side. So we'll see what we can do about it. Goodness. Alright. Gotta move this a little bit. Let's see if that makes a difference. And you know what? Let's switch over to using the hand plane on this side. Let's see if that... Okay, so now we're at the point where we can start to test this joint to see if it's actually flat. Use a straight edge and see. So I have a hump right here. I have a hump right here. Hump across here. Hump right here. There. Yeah. So I want the highest point to be the edges. In fact, I want the interior to be kind of hollowed out. Okay, so I got a good amount of work to do, but overall it's getting there. So here, since I don't want to get onto the edge, what I do is I start the plane blade in the middle of the wood, take it in, and lift. Okay, now I am purposefully hollowing it out. Let's see how we're doing. That's pretty good. Pretty good. Good. Overall pretty good. Nice. Okay. Excellent. Now that surface is prepped and ready to go. Now let's work on this 45-degree chamfer right here.